Hello and welcome to the 12th in my series of presentations on the conflict between science and creationism. Today I'm going to be talking about the subject of geology, the science of the Earth and the rocks and minerals of which it's composed. In particular, I'll be looking at a number of claims made in the presentations of the infamous young Earth creationist Kent Hovind. This means that I won't be covering the whole topic of geology, and I won't even be covering it in any sensible order. I'll just discuss the topics that Hovind specifically mentions. Lots of these arguments are dealt with in the wonderful archive on talkorigins.org. Please search for their extremely detailed site and read their much more thorough rebuttals of these claims. You can find many of the arguments that I've used here on that site. However, I've added in a few extra bits to bring the coverage up to date. In contrast to my last presentation, I think this one is the longest in the entire series, so I'm going to try to move through the slides as quickly as possible. This also partly explains why it's taken me so long to get this presentation completed. Apologies for that. Subsequent presentations should be much more regular. Most of these arguments, though often requiring complex details of specific regional geology, all boil down to one of three simple misunderstandings. So in no particular order: 1. Claims that there are some features on Earth that appear to have taken a long time to form, but which may have been formed in a few thousands of years or less. 2. Claims questioning the validity of the geological column, that is, the layering of older rock layers underneath newer ones. And 3. Claims that we can't rely on certain geological methods of dating, especially those using ice cores. There are also several miscellaneous topics that I'll intersperse among these three main groups. Many of these are wonderful proofs of the antiquity of the Earth, so Hovind understandably assaults them. Fortunately, his assaults are not very convincing. So without further delay, let's get started. The Earth is an enormous planet, and the forces that operate within it work on a very long timescale. The surface of the Earth, broken down into massive tectonic plates, glides at an extraordinarily slow rate over an ocean of liquid magma underneath. Europe and America are sliding apart at roughly the same rate that fingernails grow, a speed of a few centimetres per year. If the Earth were only a few thousand years old, then this separation of the continents would have shifted them only around a few hundred metres, give or take a bit. But we have a very good reason to believe from various sources that the continents have moved a great deal more than this. In fact, we have a very good reason to believe that the continents as we see them now were once joined together and have moved a very great distance since that time. The supercontinent of Pangea formed in the early Permian period around 250 to 225 million years ago and began to break up by the Jurassic period, maybe 100 million years later. We have a number of reasons to believe this, so here's a few. Firstly, we see underlying geologic beds which run from one continent to another, as if they were right alongside each other, though they are now separated by thousands of kilometres. The best examples concern South America and Africa, where very distinctive rock strata run right through, say, Brazil, then suddenly stop as they reach the Atlantic coast, and then a few thousand kilometres to the east, on the west coast of Africa, the strata miraculously reappear, with the same rocks in the same order, with the same relative widths. Secondly, we can investigate the distribution of fossils. We know that animals that evolve on separate continents may evolve into similar niches, but are likely to do so in remarkably different ways. So when we see very similar fossils on the edges of two continents that are separated today by a wide ocean, then we should look at these very closely, because the chance of them having evolved exactly identical forms in two areas that are so far apart is extremely small. The well-measured and thoroughly accepted process of continental drift gives us a model for how this may have happened. Thirdly, we can see glacial deposits of similar ages across all the continents, which tends to hint that the continents were all in polar latitudes at a similar time. Whereas today, with the continents separated as they are, some continents are polar, such as Antarctica and the extremities of northern Europe and America, whereas others are tropical, such as most of Africa, Central America and South Asia. There are other reasons, of course. The outlines of many continents seem to fit together like a jigsaw, especially if you examine the Atlantic coasts of South America and Africa, for example. But that's not really a cast-iron proof of the Pangea theory, so it can be taken as an interesting support for the theory, but it doesn't stand on its own. But I'm sure you'll agree that the rest of the proofs that I've shown in this slide are very convincing. Another consequence of the fact of tectonic drift is the phenomenon of ocean floor magnetic reversals. This gives us another great demonstration of the age of the Earth. The mid-Atlantic ridge is a volcanic range in the middle of the Atlantic Ocean. The ocean floor is being formed either side at the rate of roughly 1 centimetre per year, and hence the sea floor is gradually shifting away from its point of creation and towards either side at roughly the same rate. The interesting thing is that if you track the rocks either side of the ridge, you can tell the direction that the Earth's magnetic field was pointing when the rocks were formed. That's because basalt, the rock in question, retains an imprint of the prevailing magnetic field direction when it cools. We can see bands of magnetic reversals across the ocean floor, showing when the magnetic field of the Earth reversed, a phenomenon that happens roughly every few 100,000 years. The conclusion is striking. You're watching the Earth's surface being created as the Atlantic zips at the midpoint almost exactly halfway between Africa and South America, and we can see these extraordinary stripe patterns either side of the central ridge. But of course we know how wide these stripes are, and we know the speed at which the ocean floor is moving apart, so that gives us a very good idea of how long this process has been going on for. Every kilometre in stripe width equals 2 kilometres of separation between the continents either side of the ridge, as there is a stripe on either side. And this separation rate is well measured, and for the mid-Atlantic ridge is around 2 centimetres per year. So that means that a kilometre in stripe width equates to 100,000 years of continental drift. And the fact that the stripes are symmetric, that is, the widths correspond on either side of the central ridge, is impossible to explain by any other mechanism. The only sensible conclusion is that the ocean floor has been spreading very slowly and has been doing so for millions of years. If you've seen footage of an oil well squirting out oil many metres into the air, then you'll probably realise that oil is stored underground at a very high pressure. The pressure is high enough that not only can the oil reach from the miles underground right up to the surface, but will then jet through the air in a magnificent fountain. But if oil pressure is so high, then surely it can't have been underground for very long. After all, it would bleed away rather rapidly, wouldn't it? Well, there are two main errors with this view. Firstly, oil is held beneath impermeable rock layers in the oil reservoirs under the Earth. These layers do not permit the oil to leak through, so unless they're disrupted by major tectonic activity, or a drill, the oil can stay there indefinitely. Secondly, just because oil may have recently seeped into a reservoir underground under high pressure, and that pressure may eventually relax as the oil spreads out, that doesn't mean that the oil itself is young, merely that it has not been in its present location for long. Think of the analogy of a river. Sure, water can flow from the top of a mountain to the sea in a few days, but that doesn't mean that the water is only a few days old. Other processes are at work shifting it around the Earth. Debates over ice core science usually boil down to a few simple misunderstandings, though the concept of ice core dating is actually quite complex. The most interesting misconception is that few people realise how dry places like Antarctica are, most of which is technically considered a desert. The amount of rainfall as snow is only a few centimetres per year in most of the parts where ice cores are taken. Once this has been compacted and sheared by bulk motion of the ice body, a metre of ice core can correspond to hundreds of years of deposition. We can measure the age of shallow ice cores by directly counting the layers. To those who object to the possibility of thawing and refreezing creating artificially high numbers of layers, firstly, that only happens where it's warm enough, and there are plenty of parts of Antarctica where the temperature never gets above freezing point. Secondly, the ice cores from the last 1,000 years or so can be reliably cross-checked with known events in the history of the planet, such as major volcanic eruptions, which leave traces of volcanic dust in the cores. They show that the assumption of one layer per year holds perfectly over extremely long periods of time. It is, of course, obvious that the existence of such ice cores, which show no substantial sediment whatsoever, are conclusive proof that there has been no global flood in the last few 100,000 years either. In July 1942, a squadron of aircraft were abandoned in Greenland en route to the UK to take part in the war against Germany. The squadron included 6 P-38 Lightning aircraft and an escort of 2 B-17 bombers. They had flown from the tip of Newfoundland over Greenland and on to Reykjavik, Iceland, en route to the UK. Over Iceland they ran into heavy cloud and were eventually forced to turn around and return to a base in Greenland. Weather conditions were no better over Greenland, however. With wings icing up and fuel reserves declining, the planes were forced to make a landing, one by one. Once they were all on the ground, the 25 airmen were stranded on the ice. The story of their eventual rescue was the subject of a book called The Lost Squadron by David Hayes. In 1985, archaeologists and enthusiasts attempted to locate the Lost Squadron in Greenland and were surprised to discover that they were to be found under a depth of approximately 80 metres of ice. But if ice can accumulate 80 metres in just over 40 years, or almost 2 metres per year, doesn't that effectively destroy the science of ice core analysis? The EPICA core, the European project for ice coring in Antarctica, was created by drilling to a depth of 3,270 metres, or more than 2 miles, and is said to cover a period of 740,000 years. If snow accumulates at a rate of 2 metres per year, then this core couldn't be any older than 1,635 years, could it? There are three obvious flaws with this logic, that should be fairly obvious. Most importantly, the thickness of a layer of an ice core is directly related to its depth, and therefore its age. The upper layers are much less heavily compacted than lower layers. For example, the lowest 100,000 years, about 14% of the timescale, in the Epica core, are only 100 metres of the ice core, only around 3% of the length of the core. Secondly, Greenland is very different from Antarctica. Antarctica is considered to be a desert simply because there's virtually no snow there. The total annual snowfall is approximately 2 or 3 centimetres, not 2 metres per year. Thirdly, and less obviously, it turns out that the Greenland Lost Squadron landed on a glacier. Antarctic ice cores are not taken from active glaciers for obvious reasons. The ice layers have to be absolutely stable. Ice core science is very well established, and this is yet another argument based fundamentally around ignorance, plus the rather arrogant assumption that a flaw so obvious that Hovind has spotted it and understands it easily might have been missed by the thousands of PhD scientists who have worked in this field for decades. You'll see this tactic quite regularly in Hovind's work, and in fact the work of most young Earth creationists. Ocean salination is an issue that some creationists bring up. It's another example of a poor extrapolation from incorrect initial conditions. The salt from the land is being leached into the oceans at a high rate. This is not in doubt, and it explains why the oceans are salty. Hovind and others claim that this proves that the oceans are not very old, because otherwise they would be almost pure salt. However, they underestimate the amount of salt that is taken out of the system by various methods, which nicely balances the inflow. On this slide you can see an estimate of the amount of salt taken out of the sea each year by various processes. Niagara Falls, the breathtaking series of waterfalls on the border between the United States and Canada, are probably less than 10,000 years old. This is, of course, irrelevant. Lots of things on Earth are less than 10,000 years old. Me, for example. But the world is certainly much older than I am. You'll see this theme crop up a lot in this presentation, so get used to it. I'm afraid there are several core flaws in Hovind's arguments that you'll see repeated time and time again. His aim is probably to shed doubt on science, but in this case he's just setting up a straw man argument. That is, something that the scientists don't actually believe. He's showing it's false and claiming it as a victory, which is a pretty underhand trick. Hovind's claim here is that mountains could erode in under 14 million years, and hence the fact that we see mountains on Earth means that the Earth is less than 14 million years old. For a start, the initial claim is not even true. Erosion rates vary with the height of a mountain. When they've eroded a little, the erosion rates slow down. Also, the present erosion rate is likely to be far higher than average because we have more mountains than average at this point in time. So it's definitely a case of unwarranted extrapolation. However, this largely misses the point. 14 million years already massively disagrees with the creationist's supposed age of the Earth. Hovind can't claim that the Earth is 6,000 years old and then point out that mountains would take only 14 million years to erode away. The problem is non-existent anyway, because mountains are constantly being created by the movement of tectonic plates, by deposition of new sediments, and by volcanic activity, so this is a doubly pointless claim. Stalactites and stalagmites are geological features which are formed in limestone caverns extremely slowly by the accumulated build-up of dissolved calcium carbonate. However, there are other ways of producing very similar structures much more rapidly. For example, gypsum, a salt of calcium sulfate, can form stalactites much more rapidly, but that's irrelevant. The absolute maximum mean formation rate for a stalactite is around 10 centimetres for every 1,000 years, or approximately the thickness of a human hair per year. However, most growth rates are between 10 and 100 times less than this, according to a study published by the National Speleological Society in 1975. Also, limestone landscapes are clearly carved out over a very long period of time. Creationists who claim that a flood could cause it are very wrong indeed. Limestone is a hard substance. Even if you flow water past it at a tremendous rate, it's not going to wear it away, and more importantly, it won't dissolve rapidly, not unless the ocean is made so acidic that it would kill all marine life instantly. And why does anyone think that a global flood would produce incredibly high flow rates? Surely the rain would just fill up over and above the level of the land very rapidly, and then you've just got a huge global sea, as the Bible describes. So you've got a large ocean with marine currents, but not thundering torrents of water like Hovind describes. Again, this is another point where Hovind is trying to claim that the Earth is young because he thinks that something in it is young. Not only is he wrong in this case, stalactites and stalagmites can be very old indeed, but also it's still an irrelevant argument, though you can sort of see his point. For his argument to be correct, every single thing on this planet must be less than 6,000 years old, but all it takes is one single thing to be older than this, and he's wrong. Several limestone caverns have been dated to hundreds of thousands, up to millions of years old. Hovind is onto a loser here, I'm afraid. The hydroplate theory, preferred by many young Earth creationists, states that the waters for the alleged biblical flood came from under the Earth's crust, as well as from the atmosphere above the surface of the Earth as rain. The first major flaw with this theory is that water under the crust would be superheated, so that when it was released it would have cooked every living thing on the surface, including Noah and his fictional family. Secondly, another fatal flaw with this particularly daft theory is that the water had to be held down at depth for several millennia between the creation of the Earth and the flood, according to the Bible. This would not have been possible, as the rock is substantially denser than water and would therefore have forced the water to the surface very rapidly, especially if that water were under the pressures required to create the fountains described in the Bible in Genesis chapter 7 verse 11. Thirdly, giant boreholes ejecting superheated streams of water sufficient to cover the entire planet's surface to a depth of several kilometres should have excavated sediment, for example, that would have been deposited on the surface. That layer would be easily detectable, as it would have distinct characteristics of a mix of many different kinds of igneous rock all finely ground up and jumbled together. Of course, it doesn't exist. Finally, if there was once water under the crust, then it's safe to say that it could not possibly all have been ejected in the flood. This means that there should still be plenty left today, trapped under impermeable layers of rock. It will be easily detectable by seismic surveys, but of course it isn't there. I'm afraid the hydroplate theory is flawed on so many levels it can't be considered by any sensible scientists to have a shred of truth to it. Are there really fossilised trees in Antarctica? Hovind seems to think so, and surprisingly this is one of the few rare cases when he's correct about something. He claims that this is good evidence for a very rapid change in the Earth in the recent past, and perhaps, for example, a flood, depositing vegetable matter on a distant continent in which it couldn't possibly have grown. But what Hovind doesn't mention is that the fossilised vegetation that has been discovered in Antarctica dates back around 2 million years, to a time when the continent of Antarctica was further north, and before tectonic drift moved it to its current location. And if it was further north, then it was obviously much warmer. So no, the existence of ancient fossilised vegetation on Antarctica is not evidence for a flood. It's evidence for tectonic drift, and it fits in wonderfully with the other evidence we have that we've already covered earlier in this presentation. The geological column is a term used to describe the vertical arrangement of rock strata deposited over time. Creationists often claim that the column doesn't exist and that the layering was caused by the global flood, instead of slow deposition over millions of years. As you can imagine, the evidence is heavily stacked against them. For a start, there are at least 26 different locations on Earth, from the USA to China, Australia, Iran and Morocco, where the entire column exists at one place, and it agrees across a wide area. That is to say, if you drill deep at any one of those locations, you will come across roughly the exact same layering of deposits in the same order. The thicknesses will certainly differ, but the ordering will not. This precise ordering of the sediments doesn't make any sense from the theory of a flood. For example, you have sandstone, which is deposited in desert conditions, followed by a layer of limestone formed very slowly by deposition of calciferous marine creatures in shallow seas. Then this is followed by some igneous rock like granite, for example, maybe followed by another layer of sandstone. If there were a flood, for a start you wouldn't expect neat layers, you would expect everything to be jumbled up, but also you wouldn't expect such different layers to be so well divided and clear. A great example are the Haymond beds in southwestern Texas, which consist of 15,000 alternating thin layers of sand and shale, deposited in an oceanic region which encountered regular submarine landslides, creating the sandstone layers. The shale is laid down very slowly over time, but the sandstone is laid down very rapidly, as you would expect. There are very many fossils in the shale layers, which form very slowly, and very few, if any, in the sand layers, which were rapidly formed. If this formation was laid down in the 1 year-long flood of Noah, then that would mean a rate of something like 157 layers per day, or more than 6 per hour. Each time the previous inhabitants would have been killed, and a new ecosystem would have to set up shop in its place, ready to be fossilised with the next layer, etc. As you can see, the creationist position here is preposterous. In 1976 in Lompoc, California, some quarry workers discovered a whale skeleton in a layer of sediment known as Diatomaceous Earth. This soft rock is formed by the deposition of marine creatures over a very long time. However, what was unusual about this discovery was that the whale was discovered at an angle of 45 degrees, which poses all sorts of problems. For a start, if the rock formed gradually, then how did the whale remain at this angle for millions of years while the sediment formed around it? However, the solution to this riddle, which Hovin naturally neglects to mention, is that the beds themselves were also angled at 45 degrees to the horizontal, so the whale skeleton was actually lying flat within the bed in which it was fossilised. The beds were later lifted up at an angle by tectonic activity. You'd have thought that Hovin could have investigated this much more closely. After all, if he was right, it could have been a monumental find which would have rocked science, but instead it was just left as an anecdote. Strange. This should probably be in the section on fossils, but it isn't. The argument is that things can actually petrify or fossilise very quickly, in less than a century, so therefore all fossils are young. Of course, this simply does not follow. We date fossils and rocks by many methods. We don't just generate a model for how long it takes to form them and then assume that they all form in exactly this way and therefore this is their age. Also, the time taken for something to fossilise is the minimum possible age for that sample, not the maximum, so the sample could theoretically be any amount of time older than that. The Burlingame Canyon is a natural canyon formation in Washington state which formed over the period of 6 days in 1926. It was created by the floodwater from an irrigation canal which was increased by recent high rains and which carved a slice through the landscape which remains today. Creationists claim that this shows that the Grand Canyon, traditionally claimed to have formed over a very long time span, could have formed in just a year during the Great Flood. There are many problems with this, as I'm sure you can see, but let's start with the obvious. Burlingame Canyon is formed from the Touche Formation, a layer of gravel and fine sediment, not solid rock, which is remarkably easy to carve out with water. It's also, it must be said, roughly 90 million times smaller than the Grand Canyon, but let's leave that for now, except to point out that if the Grand Canyon eroded at the same rate as Burlingame, you would still need 1.5 million years for the Grand Canyon to form. How can we tell that the Grand Canyon was not formed by this mechanism? Well, the most obvious fact is that if you look at the Burlingame Canyon, it's pretty straight, as you would imagine from such an event, whereas the Grand Canyon meanders all over the place, exactly as the models of erosion from a river would predict. Also, the Burlingame Canyon has no side channels, as you would again expect from a natural slow process of erosion. The relationship between these two geological formations is basically non-existent. Coal can form very quickly, well, fairly quickly. However, to produce good quality anthracite coal takes a much longer time. The material from which coal is formed can be discerned by microscopic analysis, so you can tell whether it was made from lots of large trees after a global flood, for example, or by a far more gradual process in a swampy environment. There are plenty of deposits of good coal where the latter happens to be the case. In fact, it's usually the case. So it's beyond any doubt that our coal reserves were deposited slowly in a swampy environment. According to geologists, coal is classified as a sedimentary rock. There is, of course, plenty of other evidence for slow deposition. Coal beds often conform to river channels and often contain root systems and soil horizons. Coal is usually found with rocks that are slowly deposited, sedimentary rocks such as sandstone and limestone. There are also examples of dinosaur footprints discovered in coal formations in southeastern Utah. The story with oil isn't similar to that of coal. It forms slowly over millions of years thanks to the intense heat and pressure under the Earth's crust. Some creationists claim that oil can be produced very quickly by certain chemical processes, but this is against all the consensus opinion of all the world experts in this subject. I guess it's a question of whether you believe people who've spent their lives investigating a field in such a way that finding the truth as accurately as possible is vital for their prosperity and well-being, or a group of people who have already decided what they want to believe because they think they'll get punished if they believe anything else, and hence are attempting to do anything they can to convince others of the same thing. There are theories that oil could be formed by abiogenic processes deep within the Earth, and therefore could have been formed more quickly, but those have been fully discredited. There's some more information on this slide about the sort of conditions required for oil formation. Basically, it forms between 4 to 6 kilometres below the ground and requires warm to hot temperatures of between 50 and 120 Celsius. Oil migrates upwards very slowly indeed, in the order of several million years per kilometre of rock. Some oil gets trapped in a reservoir underground and some seeps to the surface. The world's current reserves are only an estimate based on best knowledge at this time, but the figure of around 1.4 trillion barrels is the best estimate right now. World oil production is something like 70 million barrels per day, meaning that the currently known reserves will last about another 50 or 60 years. This is a slightly bizarre claim based on the fact that dense elements such as gold and uranium were found in the Earth's crust, whereas the theory of the Earth's formation says that the Earth was largely molten in the beginning of its life, and in this state you would expect the densest elements like gold and uranium to fall to the centre of the Earth instead. This is largely true, and there are a few important comments to make about it. Firstly, it must be pointed out that there really isn't very much gold in the Earth's crust. There may well be far more towards the core. But why is there any at all? Well, the Earth's inner layers are certainly not stationary. They move around in convection currents, meaning that elements from within are continually being recycled to the outside. Heavier elements can be shifted around like this quite easily and deposited on the surface by volcanic activity. Most gold is found near volcanic regions and fault lines after all. And I think this is basically the entire explanation. Though the heavier elements such as iron and uranium predominantly fell to the centre of the Earth, the mixing was not total, and hence there's some left on the surface. Let's finish off this presentation with a few more anecdotal stories that Hovin brings up in his presentations. We already know that anecdotal evidence is more or less useless in the eyes of the scientific method, but why is that? Well, there are several reasons. For a start, we have no way of knowing whether or not the anecdotal evidence is at all true. That doesn't mean that the person telling us a story is necessarily lying. It might just be that they themselves are also mistaken. After all, anecdotes spread quickly. In fact, anecdotes may never have any malicious element to them whatsoever. It may be that every single person involved, including the originator of the story, genuinely believed that what they were saying was true. But that doesn't make it so. There's also the phenomenon colloquially known as Chinese whispers. This is where a chain of people tell each other a story one at a time with no sort of independent verification, and inevitably along the way, due to the flaws of human memory and the desire for certain people to embellish facts with more colourful story elements, the story gets changed. And finally, anecdotes may only tell us part of the story of what happened. For example, if you went to a magician's show and came back with fantastic stories about how this incredible man could saw a woman in half and then put her back together again, you probably only saw some of the story and missed a lot of what happened. You were genuinely saying what you saw happening, but what you saw was a misleading impression of what actually happened. You were conned by a simple trick in this case. So all in all, anecdotes have no use whatsoever in science. They're not controlled, they're not verifiable, they're not repeatable, and they're not trustworthy. And for that reason, the true scientist doesn't have any need whatsoever to refute them. The overwhelming story from this rather long presentation is that there are really few novelties in the creationist complaints about geology. Most of them are concerned either with misunderstandings or, in the majority of cases, the claim that something could have formed more quickly than true scientific theories suggest. But the fact that one feature can be formed in a few thousands of years has no bearing whatsoever on the age of the Earth. The Earth isn't dated based on the age of Niagara Falls or a few stalactites. The age of the Earth is the result of thousands of different experiments and measurements, all taken independently with thousands of different techniques by different people in different times and ways, all of which converge on the absolute certainty that this planet is very old indeed. Well, that's all for now. As ever, there's loads more information on my website at frame.net, where you can also find a transcript of this talk and all the following ones, and all the previous ones, and you can keep up to date with my blog as well as learning about some of my other work. See you next time when I'll be talking about the science of physics and covering a few points that you may have seen me mention briefly on previous presentations, but which I think need to be dealt with in a bit more detail. Thanks for listening.